forgot. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and typing systems and whether or not AI will ever write a reasonable program. We've got a new guy today, Ryan, who said he was willing to talk a little bit about Quxlang. You want to go?
Sure. Yeah, so I'm trying to build a new programming language. I'm naming it Quxlang for now. It's trying to be like a C++ style language. So what I'm trying to do is build a systems programming language. But it is like it's making a few changes. So I'm trying to make it compile fast, kind of like Go. So that's one of the goals, and it also has like no header files, so it'll use like modules. Um, and
You got
I'm
links?
Yes, I do. There is actually, if you just Google search it, it will show up. So I've got a blog, and then I've got a GitLab. So it's gitlab.com/rpnx/Quxlang. Um, but the yeah, I probably should
Functums.
update them. Yeah, that's just
Functonoid.
that's terminology that I kind of built around the language. So, um, like C++ is very verbose, where it's like template, partial, overload, specialization set, or whatever. And I'm like,
Yeah,
okay, I'm just
right,
gonna create a word. This
right.
this is a functum or something, you know. So I did some of that. There's also a YouTube, which is probably more useful if you want to see like the status of the language. Um, and then I guess, can I share my screen?
Just a second. I have to go bring up the share options here. No, 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 no. I try now.
Okay, let's see here. Working. Window. Okay. Allow. Can you see?
Yeah.
Okay. So this is kind of the. I'm just making some changes here. So probably stash those while I do a demo here. Um, but yeah. So this is kind of the syntax that I'm going for. So it looks a little bit like Fortran, but what I've done is made all the keywords in uppercase. So I've seen languages like Zig, which have a lot of nice things, but they kind of make the language like they keep changing things that break backwards compatibility. So what I was trying to do here is make it so that the keywords are all uppercase, and so as I add new features to the language, uh, it will introduce a new keyword, but that won't break any code because all the keywords are uppercase and then all the identifiers are lowercase. So
Do
if
you
you see
check that
something,
or do you enforce that or is it just a warning or something?
it's enforced. You can't declare an identifier in uppercase.
All right,
So
nice.
if it's uppercase, it's always a keyword, and you can't do anything in uppercase unless matches a keyword. Um, so that's like part of the syntax is that identifiers are lowercase and underscores and potentially numbers.
Hey,
And
What what's
then
what's the syntax on line 72?
72. So this is x.z equals y pointer to thing. So this is getting a pointer to y. So y is I32, and then x.z. We go down here, find the class here. So there's
So
Yeah.
instead of like an ampersand or an asterisk as a prefix, you put it as a postfix operator or something.
yes, so it's a
All
postfix
right.
operator. So pointers are like an arrow. This is what's called an instance pointer, and then this one down here is an array pointer. So this is like pointing to one object, and then this one is pointing to an object within an array. So you can do pointer arithmetic with array pointers, but not with instance pointers. And the reasoning for that is that I wanted to like make it more clear when you have a function call and there's an API. If you're doing an operation only on one object, I feel like having a separate type for a pointer to one object versus a pointer to somewhere in an array is kind of a useful thing to have. Um, so like a standard pattern of this language is like name what is the thing we're talking about? What is it? And then kind of the information comes afterwards. So, for example, this is saying .z is a variable and is a type of pointer to I32, which is 32-bit integer, kind of like int in C, C++, but always fixed size. And then this is like whatever the size of a pointer is, basically. Um, so this is so special functions are like keyword functions. So because this is a special function, it's a keyword. So you can sometimes name things with keywords if the name has a special meaning. So that's why it has like a uppercase name. So this is like the destructor. This is just conversion to a Boolean. And so this is like .z value pointed by equals, .z value pointed by +1.
Yeah, bumping a
And
Z field. Yeah. So
yeah,
wait, so back up a second here. What is the goal of this language? Why are you doing this besides learning what the hell's going on in life?
well, I wanted to like improve upon C++. So one of the things, like if you'll see this Yak class, for example, I am able to use this up here. So this Yak is being used right here for this variable, but I actually declared it down here, and I didn't need to like create a header file for that. So there's no need to have like headers, and especially like when templates get involved and you have like partial specializations of templates, it gets very, very messy with that kind of stuff. So what I wanted to do is like have that be a little bit easier on the programmer, where you're not like having to mess with these headers and make sure they're all in the right order. And then like I
Right.
spend a lot of
You're
time like
clearly
compiling something.
right. You're clearly not C++ syntax. So this is not like I want to say an improvement over. This is hard sideways from C++. Plus, okay,
I
yeah,
don't think
handle forward references.
I think it's very similar because it's like the syntax is more like Go, but the semantics is a lot more similar to C++, where we have like constructors, destructors, and function overloading and stuff like that. So like I've brought in like there's some like hacks for inclusive in C++, and I've just kind of made it like a keyword where you can just have something that evaluates to a Boolean. And then like const_expr is something that I've been working on. So like these are like const_expr tests that test that the const_expr works,
Right.
and it evaluates the function, kind of similar to how you would do this in C++. So you could use that as like a template parameter and do
Hmm.
const_expr stuff. Um, and then I've got like a virtual machine that's executing stuff in const_expr as well for now.
Right.
Um,
Yeah. Okay.
Let me see. So like
All
you
right.
could do.
I'm going to wrap it up. We can come back, but Simon wanted to talk about some stuff and then go to bed. So I want to let Simon have a chance to talk,
All
and
right.
then we can come back and visit this thing again.
Sure.
Do you want to share the Google Doc? I
I can do that.
put all my things in writing.
Yes. Let me go find the Google Doc here. Okay.
All right, first topic. I worked on number literals and on specifically on the highlighting of number literals and even more specifically on highlighting it with simple grammars that text editors or IDEs or other tools use, and not with syntax highlighting based on some language server protocol. And it turns out that's actually quite easy to get started because these grammars are very forgiving, which is an interesting insight because you write a regex, which of course limits what you can do, but often it's fine. You write the regex and the things that match
Okay.
are colored, and you don't need to represent your whole uh, grammar at once, but you can extend these grammars piece by piece, and that's a really huge benefit. And one of the insights there was that I kind of feel less and less the the need to have something like tree sitter. It feels like the niche of tree sitter is very, very tiny between the easy grammars that get you started and the IDE plugin or the LSP server that you need to come up anyway. So it's also an
I mean, I
insight.
lived with regex color highlighting for decades.
Yeah,
It's not a terrible
exactly.
answer.
And I've implemented in that language grammar for my language some specific highlighting for numbers. And you see it in the example. I made a choice to use different colors for different part of the number literals. And the difference is quite remarkable because before I always felt that the type prefixes were very hard to distinguish. So where is like the number of the number literal and where is the type
The prefix or the suffix? You have
suffix?
your suffixes are very, I would say, unusual in a language.
Because it's like the lowercase suffixes are kind of fine, like the E64 or E32 or the U8, where what I found really hard to read is the floating point type suffixes, like the F32 and the F64, because like the F is also a letter that feels uppercase, so the I doesn't have like this notch in the visual representation to see where the number ends and the type suffix begins. So
I guess
it feels, sorry.
I'm asking, I'm curious about a different question, which is, oh, Theodore got booted. Let me, sorry. Why, like the second one down, zero I64? Why have a suffix? Isn't this just like not necessary here?
Let me see the zero I6. Yeah, in that case, the suffix is unnecessary. I just basically tried to write as many variations
Okay,
as I'm currently supporting. So the 64-bit numbers are the default. So the 0 and the 0i64
okay.
amounts to the same
But
thing.
then on the 127 U8, again, can't you either infer or coerce? Why do I need to say U8
Exactly.
to
Yeah, I could, but I don't want to. So the it's like a general design philosophy that I learned the hard way with Scala and other languages before that messing around with implicit numeric conversions is a game you can only lose. Sometimes a verse and sometimes not so verse, but every choice you make in that area is basically a losing one, and the only way to win is not to play.
I
So
see. I guess I've lived
I
with this, with very specific, this kind of thing for a very, very long time, and it never doesn't seem to have hurt me any. Whereas I watch Cameron, where's Cameron when you need him? Yeah, and
Rust does
X
the
has
same
these kind of
thing where
conversions
it
going on
will.
too. And again, I'm like, oh my God, surely you can default 99% of this. Why are you bothering? I'm sorry, April, go.
Um, oh, yeah, yeah. I was wondering if you can't hear me, but yeah. So Rust does the same thing, and sometimes like when you have generics, and then number literals, then these might actually like make more sense. Where like you have some inline constant that you just want to have like in this particular type because it's being used in the generic type of thing, then it becomes maybe more relevant.
You mean like auto boxing an int versus a long in Java? When you say generic, you talking about boxed integers, or
Sounds similar, yeah.
are you talking about size?
Like you have a function that takes any number, um, and you know that in this case it's
Yeah,
never going to need more bits than 8.
Okay,
your default might be like 64-bit or 32-bit. So
so the function doesn't take a boxed integer, it takes a plain integer value what you know happens to be is only going to use 8 bits. And you want to pass a literal in. Is this what I'm hearing?
yeah, something like that. I can imagine that there you would want to have a inline literal where you can use the suffix to tell the type directly.
Mhm.
Just pass the damn thing. And it gets inflated to
Yeah,
64 bits, costs nothing in the hardware. That far end just uses the low 8 bits, costs nothing in the hardware. Why?
yeah, but
Why do you need to save?
if you're writing generic code, you might have const generics, and those const generics might take these numbers. And maybe at compile time in the compiler, it's perhaps a difference if you have to the 64 different states in your type system or two to three different states, I guess.
Yeah, 2 to the
Yeah,
64
but
states in your type system. You have issues in
yeah.
your type system. That's different.
Yeah, I mean that's what happens when you say I have like generics and just pass in the 64-bit number, right? But
No.
I I just digress. I mean, it's like the conversion game is not for me. I've seen it played for like 10 or 15
Fine.
years, and I've only seen losers coming
Okay.
out of that game, so I'm not doing it.
There are definitely some weird losing situations, and C and C++ with these signed and unsigned always seem to be weird or tricky,
Yeah,
lead to losing situations.
and I mean the basic thing is like you have like okay, so you have these numeric conversions and you have rules for when they apply. And the first question I always have, okay, some person in the third party library has defined their own number type. How and when do they get to participate in that magic numeric
Oh,
conversion
you
game?
tell them don't define your own number type.
See?
It's not a
Yeah,
number.
that's
It's you've defined some kind of interesting new class, say
like
big
a big,
integer or whatever. You don't get any auto
yeah,
conversions.
decimal.
You get none. You ask
Yeah,
for
and
it on demand.
that's like I have like the fundamental requirements to be consistent. If the third party author doesn't get the power, then my own standard library shouldn't get that power either.
No, that's
But
fair. But see, I would
oh,
claim the bare ints and floats don't fall into that category. You separate them out as not standard library. They are
yeah,
core language implementation. Whereas like if I want to do
true,
complex numbers, or I'm
true.
a physicist, I want to do matrix math all the time, then I want to make up a something that does algebra politely setup.
Yeah,
But is it a number? Does it take auto conversions? This I don't know.
yeah,
I
I
think
see the use
no.
cases. I
I
mean,
I
if I
had
had a, sorry, go ahead.
I had to dig up a case where I've used number like typed number literals in my engine and uh, fairly like plain but also maybe a useful case.
Yeah,
2
no,
to the power
absolutely.
of
Test
32.
cases here
2
are called for.
no, I mean like actual cases where I need to use it in like actual production code because otherwise it
Right,
doesn't compile.
right.
2 to the power of 32 minus 1 compared to some value. So now that some value does have a proper type, and the result of the 2 to the power of the 32 minus 1 will need to coerce to that type, but the 2 to the power of 32, what what function am I calling there? Because it's if it's just an untyped number literal, now you would need to like go through all the possible number literal types to
Mhm.
figure out which function gives you the proper type. And the Rust compiler just doesn't do that for you. It just says, tell me what number literal you mean here.
Yeah, and Haskell has like a list of like numeric type precedence at the module level, and I don't. It's also like not a great solution. But,
Hmm.
but Let me just finish the topic then.
Yeah, no,
And
no,
when it,
it's right. There's a
then
different
then you
story
can
to
then we can then we can
coloring,
go
which is
on. I just
I think coloring looks
yeah.
really
So
cool.
so basically, I colored the type suffixes in a different color, and at least for me, it makes a huge difference in readability because like the problem I had before is gone now. And then I thought, hey, why not also color the base prefixes in the front? And it's not as necessary as the type suffixes from my perspective, but it just looks pretty in my opinion.
It does
And then
look
I went, well, let's just color the exponent of floating point numbers too, and then we have the complete set colored, and numbers are pretty and colorful, and I'm happy how it turned out, and it turns out that the restrictions I put on my number literals are pretty much the same as some other language also picked, and yeah, was interesting to see. So, for instance, I require that the I and the U and the F in the type suffixes is always lowercase. I require that the E of the exponent is always lowercase. I require that the B of the binary prefix is always lowercase. I require that the X in the hexadecimal prefix is always lowercase. I require that hexadecimal literals are always uppercase,
yeah, that's
and
neat.
that removes like I had this text made grammar, and this was like a huge regex with like um I think 7 or 8 alternative thingies like the bar in the regex syntax, and I just kept removing these variants, and basically all my numbers can now be parsed by one. There's like one regex with no alternative inside it for each separate number type, and it's so much easier, and I'm happy because there's like variation at a place where no variation is needed. And yeah,
Right.
that's
Yeah.
the topic.
I'm agreeing with all of those upper lowercase choices. It makes sense. And the coloring does look really nice. I'm just like, do I really want to have to say I-32 or do I need a time when I have to follow 0B11, 001, whatever with I-32 and not have it be obviously I-32? So I'm interested to see cases where you had to do it or else you got the wrong answer or the wrong compile or whatever, things broke. So you had to do it. Um, but that's fine. So do the next one. What is this one?
All right. So also a bit related to the first topic is I also reworked the precedence of unary operators in my language,
Oh, there's your reading
and
minus. Yeah.
it turns out because I removed the exclamation mark as a Boolean negation already in the past, and I removed the tilde as a bitwise negation in the past. I only had plus and minus on numbers left. And if you look at how most languages do it, if you have a minus and a number literal and there is stuff happening after the number literal, is that the minus is parsed last. So if I have like in this example, in the first line, I had to explicitly put parentheses around the minus 12. Otherwise, I would have taken the 12 and rotated it and then applied the minus. And from my perspective, that approach always felt kind of weird. And it was also against a design principle I have that says you should be able to read code from the left to the right, and having these unary operators apply last. So you're reading the line, and then you have to jump to see to what the unary operator applies
Right.
to. Never felt right, and
Right.
I changed that in my language, which was fairly easy, which was very nice because just It was just
Oh,
changing around the orders in which I parse expressions and binaries and unaries and stuff. And then I went through my tests and my code base, and there were so many places where I could drop the parentheses because they basically didn't serve any purpose
right.
except preventing the natural outcome that I now achieved. And so the diff is basically one change in the Rust parser and then 20 files that just drop parentheses around numbers with minuses in front of them. And pretty nice outcome. I'm happy. And for those who are interested how other languages deal with it, I linked a comparison
I'm
to
curious
you.
now. I definitely like this version, and I think I've tried for it in a couple times. Oh, here is -1 dot absolute.
So apps is basically the example function that
Yeah.
shows clearly in which order you applied the method and the unary operator. And
Oh,
I
let's
have two
see.
columns there, one where the unary or the minus is applied on a literal, and one where the minus is applied on an identifier. And it turns out there are cursed languages that handle these cases differently.
Which one? But I believe, oh, Ruby does. Oh, Scala does. Oh,
Yeah, both Ruby and Scala treat the precedence of the unary operator differently depending on whether it's a number or an identifier. And
wow. Yeah,
it
okay, I have to think about
feels
that one. That's good.
that's the worst of both worlds. But
Right,
yeah,
right.
my language there, second to the top, of course, does everything correctly. And that's all I
Definition, it
wanted to
does
show
everything.
you.
Uh-huh. But I can agree that the number should eat the minus. That's part of the number. And as soon as you make this choice, the answer for this choice should match.
Mhm.
So
I
I
think
can agree with it being
I think
correct.
the historic uh, cause or like the how this came to be is that in the past people simply didn't have this problem because you didn't have many languages where you could call
Right.
functions directly on
Yeah,
numbers. So
you
like
couldn't do the syntax. Yeah.
yeah, so the question never was this pressing
Right.
and
And the
was
other one
never
is abs was not called on a integer variable directly either. It would be abs with parens and x inside.
yeah
And even in Java, it's math.abs of x inside as
yeah.
opposed to x.abs, which makes totally more sense to me. This syntax makes a lot of sense. That's an obvious thing to do. So
And that's, I mean, that's
yeah.
kind of surprising that I'm pretty far alone with that decision. If
With
you find a language that does it the same as I do,
oh, I
please send me a
see.
link or a message.
Right. There's not very
Because
many. Everyone else says
everyone
they
else does the minus
right. Or they do the
last.
cursed one.
Yeah,
When
so
I was starting with AA, I didn't pay any attention, and it just turned out that I got the minus as a parsed function, just like you were to think. And then, of course, it's trivial change in the parser to pick it up off the number. But the following thing that implies from that is that negate needs to happen early, left to right, and it kind of
yeah.
makes sense, actually. I'm okay with that. All right, cool. Um, did you get what you wanted covered?
Yes, I got everything.
Cool, cool. I was going to do a 10-minute until people yell me down simple update, and then we can roll back around to Ryan's Quxlang choices or not, or whatever people want to do. Let's see here. What is a good? I'd probably do this.
Right. So goodbye. I'll get some sleep and
Yeah, well, sweet dreams and all that.
hopefully next time I'll be there the whole time.
Uh,
Goodbye.
da- da- Let's see here. Yeah. Okay. So simple. The original goal was to write a compiler, show how to write a compiler, do simple optimizations, generate code, get some, whatever. The language is not the focus at all. So I made some language choices that were kind of arbitrary at the time, and now they've come around a little bit, and I've been cleaning them up as I go. And the code I'm going to show you comes from this little sample programs. Like here's some trivial programs to write some. So I'm coding in anger on some simple thing. This one is go read a list of numbers, sort them, and write the list of numbers out. And it runs, it generates code, and it runs. So, and for Ryan, this is no LLVM. This is the entire project does all the code gen optimization, and everything else. But then we have choices on how to write programs. And so I was trying to sort out what I'm going to do here. Um, and I kind of, I'm just going to show off what's new now is I get methods. That's what's new. So there's a scan method. The constructor is obnoxious because I haven't got a default constructor. So the buff field is set by reading standard in. So this makes me a scanner where the input data is standard input as a string. And then I start using the scanner. Look for an open bracket, else you explode with a usage message. I make an array of numbers. It might as well be a vector or an array list. C++ vector, I think it is, of N64s. Look for the empty list. Otherwise, while you're not at the end of the buffer, go parse a number, add it to your number list. Find a comma, go again. Don't find a comma, better find a bracket or it's not a list. Parse a number, a list of numbers. Sort, and then print them out. And the dot string produces an array of characters. It's not really string class yet. And the dot write says, push it out to standard out. The write of one goes standard out. So that's sort of that piece. Here's my scanner object written in line. Struct has a mutable X, has an immutable buffer of immutable characters. So this is default for all things pointer wise. So that's an array, U8 array, and all things pointer wise are going to be immutable unless you said bang on it to make it mutable. And then here's a method call. Just, while your buffer is less than white space, bump the index and return self. And peek says, go find the character. And if you find it, skip it. And if you don't find it, return false. And number says, skip white space and then look for a minus. And then,
Wait,
yeah.
isn't that like odd? Because like peek normally means like check without deleting it because it's like
Right. So this is a thing for me doing recursive descent parsers. I need a function named which tests and consumes if it's true. And if it doesn't consume, it's false and doesn't consume.
right.
As
That shouldn't be peek though, because peek is like I'm checking it without
without doing
consuming
it,
it.
yes. And
So it should
originally
be
I
like
had another name here, and I was having it be require. I used the term require to match a required syntax and throw an error. But because of the nature of the problem to be solved here, I didn't want to have it actually throw an error right now. And by parser, I just give up if I don't.
why not next? If
It's next of character. So let's go look at where it's used here. So the usage here you're saying is if next,
yeah,
if next, if next. And I think that's not yet where I'm interested in. And one I've used in the past here. So peak is arbitrary because I also had a peak which is really doing a peak. Then I wanted it to peak and consume, and I hadn't get around doing it. And so now I would say match. Whoops. How about this? I would offer match instead of next. But I hear you. So peak is a bad name. So what I just heard was you wrote some code, Cliff, really quickly and slapped it out. You made poor choices, but you could read the code. You, Ryan, could read the code so quickly that you went to the place of these are some interestingly odd, maybe unfortunate word choices So, but you found the code readable.
Yeah, it looks a lot like C++,
Yeah, it was intended
especially
to
the
be somewhere between C and Java. It's type safe, runtime safe, no UB, no undefined behaviors, range checks, and all that kind of stuff. Uh, but my goal was so a week ago I didn't do methods. So a lot of this shit here wasn't possible. And then, buried in here, not being looked at is a lot of sys.io things. And this is basically now standard library, more or less. It's the wrong place. I need to put the standard library somewhere better. But there's a top level default import, includes C language bindings like, say, write, read, exit, there, no. Uh, I don't have overloading functions, so the copy here is just the byte-wise copy. I don't have another one. So here's the array U8, which is the string analog. Someday will become a string, um, which I use in the bubble sort to produce my output when I say print this array of numbers. And so there's an add which says grow one. There's an add a whole string list, whatever, or grow as needed, and then copy the bits in. Undo I find very useful. It just rolls the pointer back, and then the grow just does the obvious things. And I'm generating code for all this, so I actually can go run this shit directly here. Let me demo that real quick. I should get that in Emacs, and I don't have an Emacs right now. So we'll do this and go find this guy. Is that big enough font? No, you didn't share yet, so you can't see it. Ha 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 ha. How about this? Can I now move you? Can I drag you? I cannot drag. Thanks, Zoom. Is that readable? So I need a bigger font.
Yeah.
Yeah, okay. So
perfectly readable.
I'm just running this simple bat file, which is because, okay, so I missed a peak. Let me go find where I missed peak here. I didn't swap them all. Oh, here it is. What did I call it? I called it match now. Yeah, so that was a compile, execute, compile all the way out to code, and then launch the process. 4, 3, minus 99, 123, something, and there is your sorted list. So I can compile and generate code really quick and hack things. I have terrible error messages. The error message, this is a trace from the compiler dump, so it's not really an error message. It's just, this is where I threw it. I had the error, I had the location in the code. I could give you, and here is the line and number and offset and everywhere in the code where I found the missing peak name.
Yeah, I
Uh,
haven't done any error handling in mine either. It seems like I'm gonna have to probably like refactor my compiler as well and like start tracing things with like contexts and
yeah, you have I don't know what your language looks like. For me, I'm just carrying the pointer to the offset into the file. So I can point to the line number and at the point where I found the word peak and didn't find what a used peak, but there was no name peak. Um, I probably could also build up more context, say inside the top level compilation unit, inside the function, the struct scan, inside the method number. Here, we'll go back. Not helping Zoom.
it's more difficult in the like C++ style ones because you have like templates
Here.
essentially, and then you have to be like, oh, what parameters did you give this? Where did that come from? And then where did the it kind of creates like a stack.
Yeah, I don't have any template parameters. I don't have any templates here. So I don't have to deal that piece. Here, I literally have the pointer to the offset in the file where peak shows up, and I don't have a peak method now because I renamed it match. So I could tell you, I don't find a peak anywhere. and show you the line offset. And that's just the parser tracking. So I'm sorry, say again what you were having issues with in your version of things.
Oh, I was just saying that like I would have to like create a stack of like to because like everything's a template essentially. Where if I'm compiling something, I've got a set of parameters that we instantiate the function with, and then um, I guess this comes back to those like terms that I made up, which is like a functonoid is like if you take all the parameters of a function that are like template parameters and you set them to a specific type, then that's what I call a functonoid.
This would be a
Um,
specialized version of a function.
it's like an instantiated function.
Yeah, okay.
But,
The normal industry jargon is just specialized. You have a version that takes an int, and a version which takes a float, and a version which takes a byte, and a
well,
version which
well,
takes.
that's overloading. That's a little different. So that's where
Well,
No,
we
he means generics
yes,
specifically.
it's generics.
Mhm.
So generics in the realm that I've come from have all been we've already under the hood baked you down to a pointer to something, and it's
Mhm.
specifically it's a pointer to string or a pointer to person or a pointer to
No,
box or whatever. Whereas templates in my head were always could be primitives and inlined objects, like you removed the overhead, the indirection.
but
right.
that's the connotation being that the code it generates specific versions,
Yeah,
but generics kind of dynamically instantiates at the compile time or at the call site. It chooses what the type should be.
and there was a third thing running around here, which is overloads, which is different yet again.
Yeah, it's
Yeah,
different.
overloads are different, same function name, different signatures, but the
Mhm.
functions are utterly unrelated.
Yeah.
The template version would be same function name, different parameters, but
Mhm.
it's the function gets reinstantiated with the specific parameters, which is the specific parameter,
Mhm.
which is useful if you're having these primitives that you want to be directly in line, like you're building an array of primitives, and the array needs to be
Yeah.
compacted if it's bytes and expanded
Mhm.
if it's floats or complexes or whatever.
And kind of Ryan was saying that he had to track the cool jargon nowadays is the type provenance where the function is being where
Yeah,
the
okay,
function is
right. But
being
I'm saying instead
instantiated
of
with.
functonoids, it's a specialized function.
Well, no, the functonoid is like so. It, I think that specialized function is a bit ambiguous, right? Because it's like, okay, um, if I have
You
a
can share
function
if
that
you want, by the way.
Mhm.
okay,
Yeah, I don't know if that helps your conversation.
I don't know if it does, but like if I have a function that has like a certain parameter, like that in C++, that would be like a function template, right?
Mhm.
Um, but what happens if all the functions are like inherently templates, but even if they don't have any template parameters, and you do the same like process for all of them?
I would claim it would
Um,
be very normal.
Mhm.
so like it's not specialized; it's just like the
Yeah.
instantiation of the
How
function.
how do you define generics in your language? Show us.
So there's a couple of different things you can do. So one is like I can take a parameter, for example,
Mhm.
and I could create a function. Um, and I could say, okay, A is like anything. We'll call it T1,
Mhm.
and then we'll just return I don't know, I32.
Can it return the T
I
the
think you
net type?
could. I don't know
Yeah.
if that'll work or not. I guess you could do
Mhm.
T1. So
Okay.
let's see T1. Let's see if this works. Return A plus 1. So let's see. All right, so I've got this here. So this is like so any like specific parameters. I guess you could. What I don't want to do is like the C++ thing where it's like partial template overload specialization set or whatever. I mean,
Mhm. Mhm.
it gets very verbose, right?
Yeah. But
Um,
what would be the machinery? Because right now the T1 doesn't tell you anything. So in order to allow it to do something with it, you have to constrain it. Do you have some way to constrain it that the T should be at least int or should be that? Or because right now the T it would be the runtime object. You don't know any kind of information.
right.
And
So
what would you do in the
it does
function?
get instantiated. It's not a runtime thing. This happens at compile time, but T
Okay,
is
that's
just a
fine.
keyword that's like any type. So
Mhm,
I think I'll have like integer as well, and then
mhm.
something like that. I don't have that implemented yet,
If you
but
leave
like
it T, how would you use the generic type inside the body of the function?
so.
Because
Let me actually
you
go to
don't
my
know you don't know anything about T right now inside the body
right.
of the function. Yeah.
So I should be able to like um, use that. What did I call it? Yep. Uh, so I should be able to say. Uh, let me just create a simple
Mhm,
another one here. So this is like I guess C++ would call this an overload. So
mhm,
I say that these are like two separate functions,
mhm,
um, where and then we can say
mhm,
so.
mhm.
The
So
combination of the functions is like a functum. So like yip is a
mhm.
functum,
Okay,
I guess.
what does the generic bias? Because you should be able to use that in some kind generic context, but inside the body of the function of the first definition, you don't know anything about the type. So at the first
Right.
level,
Well,
then
we would
no,
know that
it's an
it.
int. Yeah, yeah,
Well, when we call the function the functum, it
yeah.
picks from the functions. So there it does
Mhm,
overload resolution. So it's going to
mhm,
pick which of these different functions are able to match against uh, the the call, and
mhm,
then it's going to instantiate that particular function into a
mhm,
functonoid. So like this is a functum. It does
mhm,
overload resolution and picks a function. So function is like I declare the code with the word function. So therefore that code is like the function. And then the
mhm.
functonoid is like what the specific settings are for the
Yeah, but
function.
here, so right now on line 117, you define a plus one. So that specifically should mean that the T type should be some kind of type that has support for addition. So that is kind of subsumed. That is kind of not assumed that
Well,
to be. But what would
yeah,
be
I
what would
guess that's
happen?
kind of the difference between like a template and a generic. In like
Yeah. Yes.
a template, which is what this is, you just compile it and then
Mm-hmm.
check if it compiles. Whereas with a generic, you kind of like
Yeah.
have some kind of constraint that says what the
Yeah.
generic type has to do in order to declare the generic.
Yeah.
Whereas with the
Because
template, you just
yeah, it has to track how does it make when you instantiate it. What does the body of the function does it make sense when you instantiate that to that type? But the problem would become what would do inside of the body of the generic function. So you have to assume that it should be some kind of compatible type with the body of the function.
What he's saying that he doesn't do the early checking, Theodore.
Yeah.
So in C++ templates, unless you use concepts, you do not check that T supports anything.
Hmm.
You just monomorphize it.
Yeah. So it's kind of
But you could add concepts, of course, something like
mm,
concepts or type classes.
yeah,
yeah.
yeah,
That's
yes.
actually an interesting phrase though, because C++ doesn't use the term monomorphization, and I think that that is kind of different from
No, that's
instantiation in a
exactly
way.
Yeah.
what C++ compilers do.
Yeah, Matt is right
Well,
in a sense. Yeah.
I think there's a subtle difference between like Rust invented the term monomorphization,
Hmm.
right?
Yep.
Like that didn't exist
No,
outside of
no,
No, no,
Yeah.
no, no, no.
it was decades before Rust
Yes,
even
decades.
existed.
Yeah. Yeah.
Decades before.
And the caveat should be, I believe so, the C++ can generate at runtime that type, if I'm not mistaken. At
Nothing at
runtime.
runtime. And the whole idea is basically you have parametric polymorphism. And
Yes.
that if in Haskell, for example, you have function that can still be polymorphic,
Hmm.
but then the compiler makes a function that is using type application to have an instance of that function at a particular type, and that's called monomorphization because now you have monomorphic file.
Yes.
So,
Yeah. Yeah. Yeah.
Okay. This
Okay.
code is broken.
nothing to do with Rust.
Mhm.
Okay. Well, this used to work.
Mm.
I think I broke something when I was doing something recently.
Yeah.
Yeah,
But
But
that's
the idea
fine.
should be, at the definition side, you declare an abstract type and later you instantiate it. But when you define the abstract type, in the body of that function doesn't really know. It will be checked when the type is being instantiated. Will all does all make sense at the point of call side?
that's weird. How is this null?
All right, I'm going to have you debug offline.
Yeah.
Yeah, there's something's wrong. I don't know what I did. I broke something when I was
Yeah.
adding some code recently here.
No problem. That's par for the course. I also broke something, and so I have inlining turned off at the moment because when I turn it on, I break something stupid. I'll have to go sort that out.
Yeah. Generics are hard. So yeah.
Yeah, I did this bunch of stuff with AA types and went down an entirely different path. And at some future date, I'm going to have to sort out how to bring this in together here because there's a bunch of stuff just missing here on the
Oh,
generic side, which I guess
the AA
really
goes a
bothered.
long way because it's Hindley Milner, so it doesn't have the generics in the full sense because you don't have type annotations. So you have a plus something, then the
You have
type is not declared up front, and
you have type
it can change.
annotations. You're not required to
Yeah,
annotate
not
it.
required. If you don't leave the type annotations, then at the compile the type can be instantiated to int, float, and in. So
Yeah.
this amounts. Yeah. So it's not polymorphic. It doesn't need to be polymorphic because of that.
Certainly the case. Well, okay, I'm not sure we're talking the same thing here. It's certainly the case that it allows any amount of polymorphism,
Yes.
but you don't have to declare it. It's just going to
Yeah.
happen.
Yeah. It happens after, because of
Fine.
Hindley-Milner. It happens after the fact.
It's part of the typing.
Yeah.
Yeah, okay. Yeah, fine. I haven't thought what to do about this with the context of simple. I probably should not bother. There is another theory on simple is I should close it down at some point and declare it done.
Mm. Mm.
I'm language hacking, language design hacking. It's been a fun trip. Kind of still thinking I want to throw in single inheritance into simple.
That would be more u-
Well,
useful.
yeah, yeah, it's a big pile of use, but actually more useful at this point to get proper error messages out and finish off the runtime exception, whatever you crash, you did something stupid, runtime exceptions, and get them report properly. It's just a panic right now. It's not a stack trace. I think it would be good there. Hey, Aaron.
I find more and more that I prefer composition to inheritance, that I want to have my logger object and then have lots of things that just have logger objects in them than, oh, this also inherits logger.
I see. Well, okay. I mean, you should be able to have both.
Like when I first started writing Python, I frequently had stuff that had mix-ins in it, and my class would inherit from 7 different classes.
And now it's just composition works easier.
And now it's like, actually, I just need an object that performs this task. And for my classes that need to have that object, have one.
They just have one. Yeah. 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 I use in the design of most of the programs I've done, I use inheritance first and composition second. Composition definitely happens, but there are some core things that feel better as inheritance. But maybe the answer is that we should just have language support both.
Do you have an example of something that really feels better as an inheritance than as a composition?
Well, the IR and sea of nodes. So it's very shallow, bushy IR. I have a base node class he's got 50 subclasses that extend with abstract multi-divide, function call, parameter, region, merge, blah, 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 1,000 things. Maybe 75 or something things. And then within there, I actually stack another few layers, like there's control flow nodes all inherit so they can have an immediate dominator call that they all share, shit like that. So that's one that feels good to me being as single inheritance. I get a bunch of useful sharing out of it.
Is that because you want to put them all in collection types? This is a list of nodes and it doesn't really care what type of nodes you are?
It happens a lot. A node typically has a bunch of inputs and a bunch of outputs, which are themselves just lists of nodes, array of nodes. And I can't usefully type them stronger than that because I don't actually know what one kind of thing is going to point to another sort of reliably.
Yeah, that
And
seems.
as a consequence, you test, is it this one or you're that one or
No,
this
you use
is
virtual calls or you
yeah.
don't care. It's a shared thing, and then
Okay.
everyone does the same behavior. That's a big one. It's a very
Mm,
common one. And the other one is I have a virtual call.
mm.
And that's actually less common because usually, uh, if you're in the list of nodes for the inputs to some other guy, you're doing
Yeah,
some common shared thing
yeah.
across all nodes.
I had that it was a tricky thing to see if the code is overrided in the subnode or it does use the virtual the node one. Which code does it use? Because in the node it's always defined. It's not missing in the implementations. And implementations choose to override it or not. And somehow while I was working on some of the chapters, I didn't quite get does it use the override or not because there are so many nodes.
So maybe we should pull up examples here. Like I have plenty of places where there's a common default and there's a handful of
Yeah,
overrides.
yeah, yeah,
And
yeah,
there's common ones that are no one ever overrides. It's just the thing. It's
yeah,
shared behavior everyone has. Every node
yes,
has a list of node inputs and node
yeah,
outputs. That's
yeah,
common
yeah.
shared.
I don't say that it's a strange things, but it's a strange thing. But it
You do.
definitely there was a place that I was confused which cause does
So
it.
you are doing both in interface inheritance as well as implementation inheritance, right? Basically.
Um,
The node is a class, is not an interface.
I have some interfaces floating around, but very few.
Yeah, but what I'm saying that if you do something like when you do code reuse, like you just said, then that's implementation inheritance, right? When you do inheritance for code reuse, when the node does something and it already has some default implementation in the base
Yeah,
class.
yeah,
Interface inheritance is if you have a class that you only inherit for the purpose of reusing its interface. Like if you have a collection of nodes and you don't know which subtype of node is that gonna go in the collection, but you know that they all are going to obey the interface of the base class. And you just want to have that interface constraint.
I have very few interface versions of things. That's
So you
all.
don't have like a collection of nodes, collections of base classes when you want to use just the base class type and
Yeah,
use the virtual dispatch.
the usual is bunch of base classes with virtual dispatch. But there
Right.
are times when I do a collection of CFG nodes, which is a subtype of
Yeah.
node, but then it itself is an abstract node in
Right,
the.
right, right. So in C++, that would be called interface inheritance. The point is not the interface keyword like in Java. The point is that you are inheriting the interface. Like if I have a vector of a base class and I only want to use the virtual functionality of this to dispatch to different implementations in different subtypes. Maybe add node has some implementation, maybe subtraction node has some implementation,
Yeah,
but the point is the dynamic dispatch.
yeah,
Hmm.
but that's called interface.
In C++, that's how you make the distinction. Either you do implementation inheritance when it's the inheritance for code reuse purposes, or you do interface inheritance when you have a pure abstract virtual base, when you have interface equals function equals to zero, when
Yeah,
it's a pure virtual function in the base class, and then you only write the concrete implementations in the subclasses.
yeah, I have a few of those definitely, and some of the major ones go that way. The idealized and compute calls for doing optimizations, those are all uh, uh, completely.
The point is that for the if you were only doing interface, then you wouldn't need in inheritance, strictly speaking, because you could do something like Rust does with traits, when the trait basically only
But
declares the interface, then you implement this in the Impl, and then you could use collection of dyn trait, which is as if you were basically having a collection of base class pointers. And then you effectively have dynamic dispatch when you use something from that collection.
well, I also have a lot of common shared behavior.
But yeah, if you have a code reuse, then that's different.
I have both. So every node has a set of inputs and outputs, and a count of them, and it's the, vector list, min, max, blah, 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 and go iterate them and walk them. And every node has a compute and an idealized call. Those are abstract and have to be implemented in the node itself is an abstract class, and every other guy has to implement them specifically. So both of these are happening at the same time.
And also equals. Yeah.
Yeah, hash and equals, and there's a bunch. Yes.
And in some of the classes, the equals is overridden to mean a specific thing because it
Yes.
makes sense.
Yeah,
And
there's
Scala
there's a
has a huge
very
problem.
long history with equals
Yeah.
in compilers and in C2 and long before Java, of course, and then in Java and in the typings as well. And one of the things is what does it mean? You only get one hash code equals combo on a class normally. Which one of the several instance variations did you want to use here? And in the case of my nodes, there are for global value numbering. So they're shallow opcode plus inputs. In the case of the type system, it's for interning, which works great for structural recursion until you have cycles. And then an equals call that does structural equals checks recursively on a cyclic structure just stack overflows and dies. So it is an error to call equals on the types. It's not bad or low performance. It's just incorrect. It's just crash.
You can always add triple equals operator, quadruple equals operator.
No, 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 no.
Mhm.
No. If you want some other kind of equals, you do what I've seen Cameron do, which is you have a hash function or a hash table, which takes the things you're keying and valuing on and the functions for hash and for equality as separate things. And therefore you can change how you want to hash your keys and equals your keys on a table by table basis. But yeah, separate them all out if you're going to do that. I very rarely, I've hit this bug before, but it's very rare, where I accidentally throw a bunch of nodes into a hash table because I just want a unique list of unrelated nodes that I can find quickly by doing a lookup later. And of course, I'm using my baked in hash and equals, which declares equals on op plus inputs, which if you have screwed up and have duplicates floating around, you'll accidentally hit when you wanted a unique table. Right. So if I want a unique table, there is actually I can go get a unique table as well. Now that just ignores your equals function, just use pointers equals.
Java has the both equals and dot equals, the
Yeah,
method and
it has the identity hash table has the equals
yeah.
and system.hash code.
And in Scala, constantly I confuse them because it has an EQ, which is overridden to.
Yeah.
I will mess up that again, and it has also weak equals. The equals overridden to equals, and recently in Java 15 there was exactly that. There it doesn't compute the global value numbering. It doesn't pull the right node. If you compare, if they're exactly equals, and say no, then it's not.
Why? Because it's just
Because the equals wasn't the right equals.
it was the wrong. Okay,
It has
gotcha.
to it has to be it has to has the EQ, not the equals one. And yeah,
And then I use EQ to do specific things with equals per
yeah,
node where I have a common shared dot equals that does some basic things. And then every node implements dot EQ, which is an unfortunate name overloading with what you were running into. Yeah.
yeah, and it's a nightmare in Scala. And I was once I get an error, I've right now I'm more quick to recognize it. But in the beginning, it was a hard stare at.
Oh, yeah, Aaron. So, Aaron throws in the chat, ampersand equals. I claim equal equals should do like C++, its pointer equals, and use the word dot equals, which I thought was a reasonable, good term for it. But the operator syntax in my head should map pretty directly to some fast hardware implementation, have a cost model of it's super cheap and does nothing fancy. And as soon as I think fancy, I want to say, no, 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 put a dot function name, put a function name in there. Are you thinking,
Well, but if you
But
are
it
making
can
a
be confusing.
struct, if
well,
you're
wait,
making a
let her
struct,
go first. Sorry, Matt.
sorry, go ahead.
It can be confusing when you have different concepts of equals that you just have to know by convention.
That's where I'm at. I have
So I
different
saw a
concepts.
system
Okay.
that had URI comparisons, and they had .eq that would compare the two URIs. Does this string equal that string? And they had .equals, which was doing things like ignoring the fragment because that didn't get sent to the server and not caring about HTTP versus HTTPS, and was a more flexible fuzzy match. But
Right.
you just had to train all the new hires that .eq and .equals meant different things.
That's where I'm at.
Yeah, I don't really like when languages are like, oh, you can't use equal equals because that compares the object's addresses. Like, if I do equals, I want to check if the objects have the same content. Like,
Okay, but wait, you just said something. I want to check that the objects have same contents. Do you mean bitwise contents, or you have some semantic equality check?
well, obviously this they should be like the same logically, right? So
Okay,
if
hang on.
if I have
So now I'm doing global value numbering in a compiler. I want to say I have two physically different pieces of code, different places, and they have same inputs and same function, but there are two of them, and I want them to compare equals under a test which says you are globally valuing the same, you're producing the same global value. There's another version of this which says I have some nodes, I have a bag of them, I'm collecting them together, and I want to know uniquely are you in this set or not? Because I have to do something special to you because I'm inlining and I'm cloning the body or whatever. It has nothing to do with global value numbering, and I don't want it to be confused. And immediately I have two different versions of equality I'm interested in. One that
yeah,
says it's bitwise the same thing, one that says that there's a logical notion which is up to me to define as the compiler writer and has nothing to do with the logical notion of equality that the Social Security Administration uses to pick names between people. So which equals are we talking here? And why
well,
must I have exactly one? And why
well,
is your choice the right one?
so if you have a value and you're comparing two objects, equals equals should check their contents. But if you want to compare the pointers, then you're comparing the pointers. You're not comparing the objects.
Okay, and I have a different a different notion for global value numbering. They are not exactly bit for bit equals. And there might be
Yeah,
other kind of fuzzy equals, like Aaron's test case, where the URIs are going to throw some portions away because they're not interesting in this version.
Well,
the second you start saying, "Oh, I'm going to compare the contents," well, now we have like a bunch of like little iffy sort of like language lawyery questions, which are like, "What is the contents? Like, does the padding count as part of
Oh,
the contents?"
oh
Which is a
dear, I
nasty
didn't think
case that
about
comes up.
padding.
But if you say, "Oh, comparisons defined by memcomp," then you might have to worry about the fact that the padding actually does count. I run into that myself because for my global value numbering, I for the most part just do a trivial what's it called? I mostly do like a trivial byte for byte compare, and so I just like try to like avoid any sort of padding because it's really annoying to deal with that way.
Memcomp. Well, you
Yeah,
initialize all your data structures to 0, and then your padding's empty.
yeah,
Sorry.
yeah. But the yeah, it's you can get into nasty cases like that. So it's like, oh, okay, so that might not be what content means. Like, do we want to do like a per field compare? It's like, okay, we could we could go down that route, but now
And
we've got
then you got floating point nans.
yeah. Yeah, we've now got questions of like what is equality when it comes to like field for field? Is like is a float against another float? Is that yeah, is a nan equal to a nan? And the answer is no, but it depends on who you ask.
Yeah. All right. So equals, equalities, whatever. I claim there are several useful decisions, and languages pick one. But so for me, I want the operator version to be the simplest possible one.
I just wanted to point out that it's not necessarily the simplest if you compare with the pointers, because if you have a struct with a single scalar or even two scalar, it's still better to compare by value because you avoid pointering direction. So if you're just wrapping a simple number, 32-bit number, 32-bit int, or 64-bit int, you really want to compare just the number. You don't want to take into account that it's a struct. Oh, and what does the struct has as a global value, or what is the address of that struct, and compare the address.
If I'm dealing with structs and I have already given up on values, I have identity, then the equals check, for me at least, the equals check wants to do the identity first as the equal equals, the simple one. Now, if I still have values, then there's no memory space. Now you have to do something with the bits, and then you're into walk the bits, and then memcomp and padding are your friends or your interested neighbors or something. Yeah.
But it is really nice to have struct-like value objects.
Oh yeah.
My
Absolutely.
complex number, I don't want to be an object with identity. I want my complex number to be
Yeah.
a value.
Absolutely. I'm not saying
Yeah.
that you should or you shouldn't. I'm just saying as soon as you have identities, then I want equal equals to be on those identities. If you don't have
And,
identities, you don't.
and C of node include its argument. So you can
The
Yeah.
nodes in C of nodes all have identity to begin with because they represent whatever you wrote as programmatic text. And then the value numbering says, oh, you wrote the same thing repeatedly. I'm just folding you up. Just like gzip removes commonality, I'm removing commonality.
It also vectorizes better if you compare by value. Because again, if you have a struct with two 32-bit ints, you can just vectorize the comparison with this. But if you compare this by identities, you have those indirection references floating
But
around in memory.
but Matt, we're back around to did you have identities at all? Why did you have identities if you didn't want them? It's
Yeah,
like
that if you have values, then of course, yeah, better
as
have
I'm saying, if
values.
you have identities, now you have another choice and another decision. If you don't have identities, you don't.
Well, here's the question: is this more like about the syntax of your language, where you don't want equals equals to be more than just a bitwise comparison, or is this like all about the compiler internals? Because I feel like how you optimize things and the way that the language behaves are two different things.
It's how you think about the problem. If you have identities, then you're at a point where you have to make the decision. They are identically equal. They are some other logical notion, which I'm going to make up in a minute, equals, but not identically equal. There's another layer to your thinking process. When you have values, it's easy to go to the bitwise. They are bitwise equals, but then you have to deal with padding or whatever it means to be values. And then if you're doing field by field, you have to say, oh, recursively ask the same question. Am I talking about pointer equalities within the fields? Nans versus floats? There's kind of layers to it.
For what I plan to do, if you declare a struct, right? I have like the concept, I guess, of a data type, and if you don't put struct, if you add a struct that has data types, it'll just recursively compare the fields. But if you put a pointer in there, you're not a data type unless you define like in your operator overloading what it means to be equals. So you would have to.
So when you have a data type, you're going to require some sort of equals check, which is just like Java claiming you have to put an equals in somewhere. And there's a default one that's easy. But the question is, can I ask the question, are you identically equal? Separate from the question, are you logically equal?
I don't see any reason to expose that to the programmers though. Like,
yeah, Scala
We just
has
gave a
a
bunch of examples exactly where you need to do that.
Scala. If you decline a class, the equals is reference equality. But if you define a case class, the reference, the equality is value equality, the contents of the class, not the reference
Okay,
itself. So it overrides that.
right.
When you,
I'm okay with what I'm not okay with is disallowing one of the choices. Like you cannot ever make the identity check. I think that's a bad
you,
decision.
you can still override that if you're not
And then you have
if you do not
defaults.
agree.
Right.
Yeah.
Yeah, you have defaults. Which ways it go? And I overrode it and went the other way. Whatever.
yeah, I actually don't see much of a merit to having like a way to, like, if you have a class, let's say my class is like vector of int, right? I don't really see any reason why I would want to check if those two vectors, if I have two different vector objects, I know that they don't have the same data pointer because that would violate the invariance of vector, right? Because they own their own data. So if I have two different vector objects that own their own data, they can't have, unless it's pointing to null.
I routinely do this and for huge speedups. So
Well,
I'm
then
making
that's not within the constraints of like an RAI system. Then you're just completely like you're building a different like data model, and you're not following like invariant concepts. So it's a different programming model, I guess. Is
okay, maybe it
at
is.
that point.
Here's the thing. Suppose I hand you a compiler and you run it, it's called LLVM and it's particularly slow. And I hand you another compiler that does everything LLVM does identically, except it's 1,000 times faster. Would you be interested in the faster one?
Usually,
Okay.
yeah.
Yeah, I want my compiler to run slower, said no programmer ever. Okay, so how do I get it faster? Well, there's a bunch of things I might do, but here is a thing, which is I take some high volume, commonly generated structure and intern it. And instead of having a million made, of which 1,000 are unique, I only ended up with 1,000 that were unique. Some that fits in L1 cache, and it's 100 times faster. It's because it's not going to main memory.
But
That
why do you
is
need to
a
compare identity to find that?
So now I have a set of things where I'm trying to do identity and a set of things which are logically equivalent. But when I'm done with interning, a logically equivalent becomes identity, and therefore the identity check is always just the compare the pointer and walk away. So the interning step does the logical version. The contents are the same. And then once you're done, all the remaining uses of this value are now identically equal
Yeah,
or
but you
identically
can't do
valuable.
that at runtime without a
Yes, you
large
can.
performance penalty.
Yes, I can. No, it's hugely faster. And I'm certainly doing it at runtime. What are
So
you talking
like
about?
you mean so you're
The
every
compiler,
single time you create a value, you're gonna do a tree lookup every time
no,
and then find
no,
the
no, no. At compile time, the compiler is a runtime thing. Every time the compilers that I write, including the one C2 that lives in Hotspot and has been around for 25 years, every time it makes a new type, and it makes them a lot, it does an interning step.
Maybe worth pointing out that this is kind of independent of the value comparison versus reference comparison because in C++ both LLVM and MLIR do this routinely.
Yeah.
So it's called uniquing in their documentation. But if you instantiate MLIR context and then you create a new type within MLIR module referring to that context, it's going to be, you can think of this as caching. This type,
Yep.
it could be some complicated tensor of 32 by 37 by F16 or whatever. You don't want to construct this type every single type, every single type you refer to this type. So you just cache this once. And on the subsequent calls to the type creation routines, you're actually going to be reusing this type from the context where it lives. So
right.
MLIR context owns this. That's the ownership model, is that you have one class instance that's going to own the created objects, and then you can always call identity comparison on those. And if you are doing your own programming language, I imagine you might as well add a special member function like ID, and then the user can do always compare a.id equals b.id. So it's not as if you lose the ability to do identity comparisons if you have value comparisons by default. You can always do one on top of the other.
Well, actually, in the case of LLVM, I question why you wouldn't want an identity comparison in that case because you just compare the pointers, right? Because if you have two pointers,
Just compare the pointers is identity
It's
comparison in
yes,
practice. That's
yes,
exactly what it is.
yes.
but it's okay. But if I have two objects that have the same data inside them, bit by bit, but they have different addresses, like that wouldn't even
Stop right
occur.
there. That's the responsibility of the uniquing system to never allow that to happen.
Right.
Same content means it has to be reusing the first allocation, which means it has to be always the same address.
Right, but this
Otherwise, it's a bug in the uniquing system.
Maybe, or you can do a Bloom filter like thing where I
No, don't
do
go
my
there yet.
identity comparison that says these are either the same or maybe, and then I
Let,
go to the
let,
more expensive equal.
let's just see if Ryan's got this sorted out yet because Matt's definitely spot on. If you blow your uniqueness, you've blown it, and then it didn't help you. But if you've got the uniqueness and it's working, okay. So now Ryan, you're coming up with a but.
Yeah, well, I guess my thing here is like if I have something that is generating unique, like with LLVM, it's going to return me a pointer. I don't need to pass around values, right? So that being said, I still could check the pointers for quality. What's wrong with checking the value? Like why does this have to be a programming language concept, I guess? Like where you say, oh, equals equals needs to do something different than a value comparison. Because if you want to check for identity, you compare the pointers or the
Yeah.
like a
How did you
reference.
compare the pointers? What
Well,
syntax did you write to compare the pointers?
just like get the pointer of A and pointer of B and then compare if they're equal. Or you could just
How did you
start
get
with
the pointer of
pointers.
A?
So ampersand A equals
Yeah,
ampersand B.
yeah. So he's saying what Aaron has wrote in the chat, which was ampersand A equals ampersand B. And what I was commenting was in the land of where you have these references at all, I would prefer where you have identity, I would prefer the equals equals to do the identity check directly. But then if you have a fancy logical user defined equals on top of that one, then it's required to be fancy. So you have to say dot equals or dot EQ or something.
Well, I think this like it makes it brings like a compilation concept into the realm of like the code that I'm writing. Like if I'm writing code, right, I want to check if some list has some value. I really don't care if like my value is equal is an int or a vector of ints. Like from a logical perspective, those are kind of the same thing. The types are different, but why should the operator change if I'm using ints versus using a vector of ints? Why should it have a different operator? Why should one be equals equals and one be dot equals? That makes to me no sense because it breaks like generic programming.
I didn't say do that. I said equal equals for ints would be ints, equal equals on references would be references. And then the step that you're trying to take is equals equals on a vector of whatever, a user-defined person object, whatever is now overloaded to mean whatever I want it to mean. And I'm stopping.
This is
Yeah,
kind of like the
we're also
difference.
kind of like there one of the issues you run into with especially programming languages is that there is like a computer that has to do objective things, and it has to have like concrete rules, and then there is a bunch of value judgments that we like layer on top. It's like when we say like, oh, you got like generics and it would break if we did it this way. It's like, well, it sounds like the offering is actually, hey, let's make equality a sort of user defined concept versus like let's say equality as a fixed rule set of structural comparisons, or maybe equality is a or like as a like a pointer compare, or like a variety of different things where it's like, okay, maybe these all get treated differently. Um, there's not there's not really a right answer. Like all of these could be made to work with what's it called, genericism. Like either via a separate comparison, or like a separate comparison function, which might be the case if you think that this case is not as important as other cases. So if you prioritize equality in a certain case, you might say, I'm going to deprioritize equality in a different case because I don't know, you just don't have that many equals to go around. Unless you're JavaScript, in which case you can just add an extra equals.
No, one more equal sign and we'll have it,
Yeah.
all of them defined.
Here's a little like thought experiment, right? I guess the argument that I see against the equals equals operator doing, like structure member field comparison is like, oh, well, equals equals should be like some fundamental thing to the compiler. But what if I'm on an architecture? Let's say I have 64-bit ints and I'm on a CPU that only has 32-bit ints. So checking if they're equal is going to basically be a function call where I'm doing multiple things. I'm going, okay, is the first half equal? Okay, yes.
But I
Is the
lived
second half
that.
equal?
And it wasn't a function call. You just
Yeah,
checked
you
two
just
sets
inline
of
that.
registers.
Yeah, but at the end of the day, like I'm still executing multiple instructions sometimes, and there's nothing like inherent about the primitives of the language that makes them special in any way,
That
right?
was the x86 32-bit machines running Java longs, which I totally lived that world.
Yeah,
Yeah,
I guess my confusion is like I don't know if at least in my personal arguments, if it hinges on there being like a single instruction, or like a single instruction, or similarly like small
No,
instruction count like sort of
but
comparison.
it hinges on there being a bounded finite amount of work, and in particular, one that doesn't depend on the types of the arguments that are defined somewhere else. Like there's not a completely user-defined thing. Like I can't call printf inside my equals,
Well,
the
well,
equal equal operator.
why would you have different rules for user-defined types versus a compiler? Like, why would you make the
Yeah,
separation between a
because
user-defined type and
because the user's not going to write IEEE 74 floating point math operators.
Well, the other reason is like, oh, the reason why the user defines the comparison is because the user defined the type.
Yeah,
right?
yeah.
But like, if I have it breaks the code where you can't use the same like algorithm or like code. Like if I have a map and I want to check if two things in the map, the key are equal,
Right.
why should I have to write the code twice? Once with primitives and once with
You don't.
non-primitives?
No. You don't have to write it twice. We're missing here. There is a preference from me that the equal equals operators have a known cost model, independent of what objects I'm comparing. There's a known cost model. Then there's the preference that says there's another equals that floats around in the universe that has an unknown cost model, does all kinds of crazy shit. I don't know what. Fine, I don't care. And there is an obvious, I want to say, there is a notion of people have many different kinds of equals, even on the same object types, and you need to distinguish between which ones and also which ones then you pick as a default is what Yas was just saying. That's like a personal choice. Which one do you like as a default? Some people went this way, some people went that way. I go to the round of equal equals does something with a known cheap cost model.
Yeah, that I
Dot
don't think the
equals to
cost model
something
should
random.
factor into it because then you break code correctness more often than like
No.
Yeah,
No,
so
sir.
that's a complicated question because the thing is when you say like, oh, it's going to be wrong in terms of correctness or it's going to be wrong in terms of this case, like, well, it's not by itself wrong. Like it's not like there's like oh, there's like an objective right or wrong answer. It's just like which are the priorities of this language. So for instance, maybe the language just cares about pointer and reference equality far more often than it does, or maybe it wants to like prioritize the simple cost model because for instance, you don't want to have like certain operators that look really primitive but aren't particularly primitive. Some people get really icky about that, especially like Zig is in that camp where they're like, we want to make things explicit. So if something looks like it is expensive, it might be. But like if something looks primitive, it's primitive.
Right,
So there's
but
no like
Ruby made the
operator
exact
overloading.
opposite
yeah.
choices. Ruby wants you to be able to override everything at every time.
Yeah.
And
There's
as a
there's certain
consequence,
languages
you
that do
get
that. And like I'd argue that like there is some of that is just like how do you prioritize your like values. But the when we say things like or I lost my train of thought. Oh yeah, so we've got the case of like let's say generics or something like that. If we wanted to imagine a hash map case, we could imagine a hash map where you just tell it, hey, what kind of equality are we testing for? Are we testing for structural equality? And you pass it a structural equality function, or things like that. And you can even make a structural equality function that is like generic if your language is capable of like that level of fanciness. And that's like kind of how you do it in Zig effectively. Like if you
I,
wanted to have a fancy hash map that said, hey, I want a fancy compare and a fancy hash function, and these are like not equals equals. These are not normal equality checks. You could do that.
I think the identity comparisons make like functional style programming very difficult if you don't use value oriented. Like C++
Wait, sorry. When you
does.
say identity comparisons, you mean like the pointer to pointer?
Yeah, yeah.
Yeah.
If I want to write code that is functional style, I expect when I declare an object that if I say object A equals object B, first I want to assume, right, if I mutate object A, that doesn't cause mutations on object B. So there's like
Well,
by
okay, so
value
then
is
we're
by
not.
value.
So
That,
we've got like a sort of like a bastardization of functional because in the functional realm you could just say, oh, I'm going to hash const things, and in which case you actually can literally just get the pointer stuff, and that's what Lisp did, where you just
yeah.
say, hey, if I have an object and it's identical to the other object, they don't mutate, so I could just like keep the
You
same
said
object.
mutation, Ryan. There's no mutation
Yeah,
in a functional
it's like
model.
if we're going functional route, then we're not going to
Right,
mutate things. In
but
which
I
case, we
guess
can hash cons, and then the identity stuff works out the same, which is how Lisp works. And I believe what other languages work that way?
Yeah, the early
Does
Lisp
Haskell hash
totally
cons?
hash cons everything.
Yeah.
yeah, well, as in C++, though, for example, you can write like functionally pure functions that operate on their inputs. They take their inputs, they produce an output, and then those can be different objects. That doesn't necessarily mean you have to do memoization or
No, it's not that you have
merging.
to. There
Sure.
can be a dramatic performance win if the right set of, if the right count and construction of things happens to do
Yeah.
memoization.
I'd argue
But
that identity comparisons especially are probably like a byproduct of like functional programming. Like we get the term hash consing from like Lisp.
yeah, but what I'm saying is like if it's so much easier to reason about the correctness of a program when your programming language is value oriented instead of reference
I
oriented.
claim that you are incorrect, that you're looking at certain kinds of worlds and not in others. So I'll hand you a cyclic data structure and say, do equality by doing structural recursion on the members, and each one in turn will be equals accordingly.
Well, you can't.
That's
You
your
wouldn't be able
equality.
to implement equality like that. Obviously, you'd have to have a set, a more complicated comparison function. But that
Okay, do
doesn't
I
mean you
want
can't.
the more complicated comparison function when I'm comparing 3 and 3? I don't. Okay, now I want different comparison functions, some which deal with cycles and some that don't.
Right. I mean, you can do that.
Okay, and now I want to say, do the expensive one or not.
I don't think that should be separate. I think if I'm writing code and I want to check if two objects are equal, I want to know if they're equal. I don't want to know if they refer to the same
But you
object.
haven't even
Okay,
defined
wait,
what
no, but
equals.
again,
No,
when we say we're equal, we're like loading that term because we've
yeah,
said,
right. What do
oh,
you mean by
equality means what I
equals?
think equality means. It's like,
So
okay,
I don't. I
yes, but
think
like
that
then you're just like right by default.
if I'm writing an algorithm, okay, and I'm doing something with an object, right? What scenario can you imagine? Like forget about the cost for a moment and just think about this world where the code executes instantly. In what world do I want to know if two objects refer to the same object other than if I'm like trying to avoid some kind of, I don't know, self-assignment and skipping over or something because it'll cause a bug.
So
Wait,
cycles, but also high repetition counts. Here's another example not to do with compilers. I am parsing a log file, say billion row challenge, but I did FinTech world log files all the time. And I parse terabytes of data. It's flowing through at this huge rate. I pull up some stupid string and I want to say it's a string. So a choice is to make a string object. Is it equals to some other string object? Maybe I'll go look up in a hash table. I'll go gather up the products that are being traded on. I'll compute the average prices and the min, the max for the day, blah, blah, blah. A million billion trades flow through, and every one I make a new string object for every trade object, and suddenly I have a million billion strings, and I both run out of memory and also I never run in cache. It's always completely cache missing because
Right, but
every
you're
string is
you're you're
different.
making this performance argument, okay? I
Yeah.
think I think this is where I differ is like if I want to make some performance optimization, that belongs under the hood. It doesn't belong in the way that users are exposed to the operators.
Okay.
Like the code that the user writes should first the simplest and like least involved method of writing code should be the method that is the most obviously behaving,
The
right? Like if I
first thing
do
I did was I wrote the program with strings and it was able to run sort of kinda. But, I don't want tomorrow's weather tomorrow, I want it today. So I had to have it faster.
Why
Now
don't
what do
I?
I do?
Why don't instead of like changing the way equals works? Why don't I just say this is not a string? This is a copy and write string. So I create like a template.
well, we don't
What's
want a
what's the
copy and write string. We
equivalence?
just want like we effectively just want like an intern string. Which
Yeah.
the thing is like, oh, strings are actually the obvious case of like why identity compares are super useful. Like the entirety of Lua is all intern strings because it's super useful to just be able to say, hey, equality is just like a pointer like a reference or like a pointer
Pointer check
comparison.
after interning. Yes, right?
Yeah.
Exactly.
But you
And
can
so
do
like
that as an
that's a super
optimization.
common case. And in the case of compilers, we have all the global value numbering stuff, but we use tables all the time for like whatever variety of goop. Hey, I've got something that needs I don't know, visited set, and for some reason I just don't keep IDs. LLVMs like that, for instance. So they use a bunch
Making
of tables.
Yeah, making this the default behavior is premature optimization, though. You're saying, oh, because this is a way that's performant, therefore I want to change the semantic meaning of this operation to be
It's
something
not
that
changing the semantic meaning. There is no semantic meaning.
Yeah,
I keep
we're
saying it over and
defining.
over again.
The thing is, you're assuming that you're like. So the problem we're getting into, and this is what I mean with the loaded stuff, is like we're assume you're basically your argument kind of starts with assume I'm right, what you're doing, what we're doing is a bastardization of what you're doing. What we're saying is that no, both of them are completely valid models. They're just about what you care about prioritizing in a programming language. So like you mentioned things like, oh, I don't care about prioritizing keeping the low level, like you don't care about prioritizing the sort of cost model or those sorts of things. Those seem like
let's
premature
look at it. Let's
optimizations.
look at an
But for
actual
us, we're like,
comparison.
what is it?
Like, let's look at like an example of these two. Like, this is, I think this like goes down to this like model of like reference oriented programming languages versus value oriented programming languages. So if you look at C++, which is value oriented, you can compare that to like Go or Java, which is reference oriented, right?
Sure.
So if I, for
C++
example,
value oriented.
I was going to say I wouldn't
yes,
call
it is.
that.
Yeah, it is one of the. There are not very many value oriented. Like Rust and C++ are languages that I would generally consider value oriented.
So let's
When we
leave
say
that
value oriented, do we
term
just
off
mean
the
like, oh, there
table.
compares work on values, or do we mean something like deeper than that?
I think it means like if I create an object and I have another object and they're both not pointers or references, they're both values. They're separate, and if I mutate one, it generally doesn't affect the other one.
That's the normal definition of values. And that's
Right?
true in Java as well.
But no, it's not true in Java, because
It
if I
absolutely
say
is true in
object
Java.
A and then I say object B equals A, those are the same object.
If I use an equal sign, I got a reference update. And that was the value. The value was the reference. And I just
Right. So it's
copied
a
the reference.
reference-oriented programming language because those are references to objects. They're not objects.
We're again kind of confusing here. We can do
If
everything
if I declare like TA, like an object of type, if I declare two variables and they are both of types of an object, and I say A equals something and then B equals A.
Yeah.
In a reference-oriented programming language,
okay,
which
fine.
includes Java, those both point to the same object.
Yeah,
they're the same.
We're missing here again.
But
you can write anything. Either of these styles can be written in either language. The syntax changes. There is a default syntax for what the equals operator means. The assignment, not equals, assignment operator does. It's different between the languages. But I can totally say B equals new of an A, new B of an A, which is a copy constructor. And I got a new instance of a B, which happens to be from an A, or an A from B, or whatever you want.
So if we're talking about the default behavior, right? In C++,
of assignment
it's
operator.
value oriented.
Yeah, but I think that's not helping with the equality issue. The thing I don't hear you acknowledging is that there are multiple different useful equality notions, and different languages pick different ones from the start as they think is what
but
it means.
if you have this object as value, then you inherently want the equality to behave as value as well. If I say A equals B, and then I want to check A equals B, I assume that comparison should equal true at this point, right? And that in any value-oriented programming language, that's just like logically something that I should be able to assume is true. But if you say that no, these are not the same object, therefore it's false, that means I can say A equals B, and then A equals B is false, and that's silly. And
not
any
necessarily. Like that's not necessarily that silly, but like I guess a simple example might just be the strings case again. Like, oh, we don't necessarily want to just compare a byte for byte every single time. When we say A equals B, we might just want to mean, oh, the pointer, because that's the easier. The thing is, we've got like effectively like this matrix, and you are like looking at the like columns, and we're like looking at the rows effectively, and like you're seeing the pattern in the columns, we're seeing a pattern in the rows. It's like, oh, it doesn't make sense in the rows. It's like, well, the pattern's in the columns. Like if you look, like I need a better way to write that metaphor because it makes so much sense in my head. But the
draw something down, bring it next time.
Yeah, I'll probably do that
because I have things to do starting a little afternoon, so I'm gonna end this one way or another close to noon, but we're not yet. 20 minutes from now.
Yeah, there's a few of these sorts of
By the way, philosophers have been arguing about this for centuries. There is this ontological principle called identity of indiscernibles, whether there can or cannot be separate objects that have all their properties in common. And to make everyone on the call feel better, it's a centuries, if not thousands of year old debate. So we probably
fine. We'll solve it by noon.
When I take the Star Trek transporter, which version is the real me?
Okay, so here's a good question. If I have an object of type T and it says A, it's named A, and another object of type T, it's named B, and I say A equals B, and then I check A equals B after that. Why does that depend on what T is? Why does that behavior change? If I say A equals B, why does the behavior of A's equality to B depend upon the type of T, whether it's an int or like a vector or struct?
Well,
See, that's the
I would
thing.
claim
Okay.
that in the land
Mind
of
you,
So let's
regardless of
take
what you
this
pick,
example.
regardless of what you pick, the answer is going to be, oh, it's going to depend on the type. So, for instance, floats, you can have a NaN float, and you can have the exact same bit pattern of a NaN float, and it will say, no, they are not
No.
the same.
Well, I would
I'm
not do
triply
that in my
special.
programming language.
So if I go back
Sure,
to the Java
you can
model,
disregard
I
these
would,
cases, but these are legitimate cases that people really do use.
Yeah.
And I, for instance, like if I'm checking for NaNs, that's how I check for NaNs because it's
Yeah.
actually really useful that they like basically contradict themselves in that way.
Yeah, I
Yeah.
think
These are
floating point
Should
types,
all nulls be
like,
equal? Should all nulls be not equal? I feel
That's
like
a good
null
point.
pointer equals null pointer should return false.
I
Yeah.
think
No,
I
no
think
pointer of
null
what?
to null, like
okay,
that one feels like I would definitely want it to be equal.
All my
floating
null
point.
pointers are like, even if null is a valid version of persons and
Yeah.
squares and cats and dogs.
Yeah, but the thing
Yeah,
is, when you say equals, that's like a random symbol. That's a set of sigils that doesn't mean anything by itself. We've got a bunch of loading that's like, oh, this means equality. And then we've got a next set of loading that says, what does equality mean? Like, equality is like a amorphous concept. It just means like whatever you need it to mean, basically.
well, I don't think it should. I think that there should be certain like logical constructs, right? Like if I set A equal to B, I expect in any like data, like if this
If I'm
behaves
using
like
Java,
a
what
data
you
type.
just said is true outside of the NaN case.
Well, it's not for objects because like
It is. Oh yeah. If I assign
well,
a
I
B
guess
to an A and they're both the same type T, then I just move the pointer and the equals will do the pointer check and
all
the
right,
pointer check will be true.
but then if I mutate A and I say A plus equals 1, then I've mutated B as well in
Now, you
Java.
can't say
That's
plus
Well,
equals
mind
on
you,
a
mind you,
reference.
this is like if you're talking about like a math, that is what equality looks like. Equality does look like they are literally the same, as in
Yeah.
like they are like fundamentally bounded to each other.
Yes.
And so like if we're talking about equality as a concept, then oh, that's exactly what that means. We're talking about like mixing equality, the fancy math thing, and you're saying like, oh, this is like the logical way of thinking about it. It's like, well, it's less about like logic, it's more about like preference. But even so, the mathy way of looking at it is that like equality doesn't like mutate things or you don't assign things. You just kind of things are.
There's no plus. There's no plus equals into
Yeah.
into
And
a
if
math
it's all
object.
and if it's all thought of in the equality concept of like, oh, mathematics or in philosophy, then things or generally things don't change, and because of that, we end up with this or within like some sort of like like set of propositions, things won't be changing. Because of that, what we could say is, hey, it's the same thing to ask about identity equalities in the same way you can have like hash counting, as it is to ask about like structural equality. Those should be the same concept if we're talking about equality in the sort of mathy sense. The
I
problem
don't
is that
think
we've
so
got a
because like
different definition of like equality that is like a programmer definition, but it is
But at
like
the same
loaded
time,
in a bunch of like programmerisms.
because like
I,
in the
I just
case
let
I
that have
think
a turn.
I just wanted to that on a conceptual level, I agree with Yasser that this is basically just a set of trade-offs, and we have different philosophies when we prioritize different trade-offs. But at the same time, one trade-off that I would underscore from the value semantics is that it does enable equational reasoning in the sense of substituting equals for equals, as if you have a rational number class and one value of that class is 1/2 and the other value is 2/4, that if you want to have the substitution equals for equals from mathematics, then you have to decide that 1/2 is going to be equal to 2/4. And from that follows you have to allow the comparison by the user-defined operator equals equals.
Yeah, that was I
Otherwise,
was.
Yeah,
otherwise
no,
you would
that's
not enable
that.
equational reasoning. But I also agree with Yasser at the higher level that this is one priority. And you may
Yeah,
or
it's
may
like yeah,
not choose
if you
that
care about
priority.
equation, like if you care about math equality and like this sort of equality in like capital E equality, then yeah, you're gonna run into like the cases of like, are these two numbers equivalent that are like two rationals that are just like effectively equivalent but represented differently, or
well
a
I think
variety of
that
different cases like that.
Right.
that is like an equivalence class. So what I guess define as the equivalence class is like a data-based equivalence class. Like here's the data that like if I serialize this
Mm.
object, what does it represent? And like how do I like if I have 3 integers, right? And that's my data. It's a vector of 3 integers. I want to check that the integers are the same. Now if I have an equation, for me equals equals if the terms and the numbers are different, they're mathematically equivalent, but that's under like a mathematical equivalence class. It's not a data equivalence class.
Yeah.
So what
Yeah,
I
so
Yeah,
want
but I guess
equality.
going back to the sort of like the motivational aspect, like why is that the useful? It's like, oh, if we serialized it, assuming I guess no like no padding is included, and we use like field equalities that, for instance, match whatever the comparisons of the things are, which ideally it sounds like you don't like floats, so maybe you just like kick floats out of the like kick
Well,
floats
I
out and
think
now
floats just change the way that you do the equals on nands, and then you fix the float problem. Then you can do dot equals or something for the floating point special version of what equals means.
Gotcha. Okay, so everything is like serialize it as a bit stream and then take those bits without the padding and then like basically equality on that. That's perfectly
Aren't there like
fine, but that is like
multiple?
just as like valid of a like equality description as, for instance, the math one that might say that 1/2 and 2/4 is the same, or the same one that might say like, oh, 2 pointers are the same, or the same one that might say, hey, let's just define a function that says what we mean. Because the thing is, because it's a value judgment, it makes the most sense to
I
just say
think
like,
that
hey,
there is one like I guess realm of if you have value oriented programming where there's certain like I guess axioms that you would want to hold, which is if you say A equals B, I want I want mutations to one object, not to affect the other object.
You're talking
So,
value oriented. There's no mutations. As soon as you say
yes,
mutations, you're not value oriented.
no, C++ has like I can declare two objects, right? A and
C++
B.
has mutations, so I claim it's not actually very value oriented.
So
when we say value oriented, are we talking about like like functional programming style?
I
No,
think
I'm
I'm trying to
no, no,
figure
no.
out.
I think it's the value semantics, and that's what Alexander Stepanov pretty much introduced to C++. But again, that's worth noting that Alexander Stepanov, in this his book of Elements of Programming, I can post the link; it's freely available, has defined a notion of regular types and regular functions, and in that notion, he defines them by enabling equality as equational reasoning principle, meaning substitute equals for equals, meaning 1/2 has to equal to quarters. So that is what is supposed to happen in a value semantic language.
Well, I would argue that if you're doing advanced computations, you're not at that point calculating like the data. So that's like a
Wait, what is
mathematical
that
No, no,
mean?
no. I mean, you will be doing computations anyway. If you are implementing std vector, then you don't want to compare all of the member data of the std vector because it's gonna have begin iterator, it's gonna have end iterator, and it's gonna have a capacity, for example. And you don't want to actually compare capacities of two vectors because you
That's true.
resized one more. No, if you want to have substitute equals for equals reasoning, and you have vectors with contents 1, 2, 3, and you have another vector with contents 1, 2, 3, you always want those two vectors to be
Right.
equal, and you do not care that the other one was resized one more time and had doubled capacity in the
Right.
meantime.
Right.
So you have to separate the salient versus non-salient members, as again was talked about in
Right.
the C++ value semantics community, and that's what your equality is going to have to be. You kind of have no choice, but
It's not doing bit by bit by bit. It's doing some user-defined logical comparison. These two vectors have the same length and the
yeah,
same numbers.
I think you have no choice but to have user defined because you have to explain to the compiler what does equality mean, because equality can mean different things.
Right.
Yeah.
But I do agree with you in terms that this is what you need for truly generic programming. Like if you want to have a generic function find, which takes two parameters, it takes parameter needle and it takes parameter haystack. And you only know that parameter needle is of type T, and parameter haystack is of type collection of T. And then if you want to write a while loop, then at some point you're gonna have iterate over all items in collection, and you want to write item equal needle. And if you want this
Exactly.
equal to always work, then for generic programming you need to define the equal to be by value.
Well,
And
Yes,
that's
that's
yes,
exactly
if
it.
you want that to be the way that you think about what's it called, equality, which might not necessarily make sense. So, for instance, let's say we
and
had
you
a
are
let's say we had
accepting floating point, you are accepting
no,
IEEE
not even
750
just
for
floating points. So,
breaking.
like for instance, let's say we had binary search and we wanted to search for something in some like sorted array. Our entries might not be the thing that we're sorting on. We might be sorting on a field of our entries. So when we say like, oh, equality, we actually mean like key equality, and key equality is separate from like the entire structure equality. And so I would just say like, oh, in these cases, just like pass in what you mean by equality. That way we don't have to like the compiler doesn't have to answer the question of like what value judgments to make for you. You just be like,
Right, but
oh, I'll just like
there's kind of a sane I guess a default, which is if I have structs and those themselves have their own definition of equality, like inheriting the value comparisons in the composite structure as a default behavior makes sense to me, unless there are pointers, in which case you say, you know what, if I have pointers in my struct, this probably has a special meaning, and therefore you should define that yourself. That should be user defined. There should be no default in that case, because that invites oopsies, right? And it breaks the potential
which
value.
very well may be right for your language.
Yeah.
When I look at
Difference between-
Rapson's notation for calculus, it doesn't feel weird to me that there's no ampersand to get the address of a thing, because that's not really what calculus is doing. And when I look at C, it's not weird to me that there is an ampersand there.
yeah. Or like I think I'm like personally at this point I'm okay with C not having equality for user defined types. Because it's just like it just gets into a bunch of like icky questions of like what does that actually end up doing, or does that end up looking like? So I'm just like, okay, user-defined types. If you want to have a language that has equality, I would just not define equality for user-defined types unless the user like specifies it. Like, there's no default one. Because then you don't run into the same assumption of like, oh, equals equals means this like specific version of it. It's like, well, no, equals equals means either like some. So like, let's say it's a pointer. Okay, pointers, pointer, floats, floats. All those are primitives. But if you have like a structure and you wanted to value compare a structure, like you have to define that. I don't know what that means.
That's
It could
fair
mean a lot
enough,
of things.
but I think that if you want generic programming, then in this model you have to always enable definition of the equals or whatever, or the function equal or whatever it is to be
That's okay.
exactly the same as for primitives. So that you still can write a function that takes needle, that takes haystack, and it's gonna work on primitive types, and it's gonna work on your types. So you don't want to back yourself into a corner that you cannot say add equality comparison to integers that are built in, because the built-in types don't allow you to override things.
Yeah,
But if
yeah,
you
but
but
again,
with this
we've already like assumed that I necessarily want that. And I've like given a case of like, find a needle in a haystack, where maybe needle in a haystack means, hey, I have an entry that has a key and a value stored in the same struct, and that's like my
so
array of keys
you
and
basically
values. I want
allow
to compare
you
keys, not
allow
values.
custom you want to allow custom binary predicate that is implementing that desired comparison
Sure,
semantics
you just
basically.
you pass it a function, or you pass it
And
what's it
then
called?
you allow it to work for primitives or non-primitives equal way, right?
Yeah, you could define an equals
Yeah.
equals. That's fine.
Then you still have generic programming. Yeah, then I don't see the
Yeah,
problem with generic programming in that model.
yeah. I guess yeah. To
Define this
I think
rephrase what
the
I meant,
problem
I
is
was
I think
saying
the
that like
problem is what Ryan may be criticizing, but maybe he's assuming that it has to be this way. But from what you said, it doesn't have to be this way. Is the Java problem, because Java really doesn't allow you to do generic programming, because Java really doesn't allow you to override what you do with primitives. Like if
you have to box
you
them.
have equality, then you have equality. Period.
sure.
So Java
I
does
would
allow
like
you to do
rephrase my thing
generics
as
with
like
primitives with the
But it doesn't
box.
have to be this way. But it doesn't have to be this way. I think that's a fair enough argument.
sure.
Well, yeah, you could
My
have
rephrasing is basically we have
okay.
equals equals, and equals equals on user defined types is just not defined. So like there's primitives, they all have defined ones. You can define one for your user defined types, but they don't come with one by default because I don't want to answer that value judgment. I just like it's complicated because like somebody's gonna come up to me and be like, hey, I've got this thing that's got like a key and value like entry. Like, how do I make an equality function that works with the rest of everything? It's like, well, you can't. You have to like somehow separate these arrays because I can't make key equality as like a subset of the equality of an entry thingy. And it's like, okay, that's annoying, but I guess you're just gonna have to define equality separately. And everything that used to use equals equals, and I used to assume that that was the good way to do things, can't work that way. Or you would just define it if you think that the case comes up that different forms of equality
Wind it
are used a
down.
lot.
Wind it down.
Yeah. If different forms of equality are used a lot, you might say, here's the prioritized one that's equals equals, and then you have the rest that are like defined as normal functions and stuff like that, and whatever.
All right,
Or maybe you define them all as functions.
I'm going to attempt to summarize to say
can I close off with something?
Really quickly. Yep.
Okay. I think that there's like, again, reference oriented versus value oriented. I think this is kind of a given. If you're doing value oriented, it makes sense to do it this way. If you don't want a value oriented programming language and you want these identity comparisons, that's a different style of language. And sure, maybe in that kind of language, it's not good. I would say value-oriented programming languages are better. That's my opinion.
Don't throw the judgment call out there, because for everyone you do, there'll be somebody who has a valid concern the other way.
Yeah.
So, but for you, it's the right way for you, and that's great.
What I actually did want to talk about, I didn't really get time to talk about this, but I did want to kind of bring up like
So there's
basically
always
why I think value-oriented programming was the better model
next
versus
week.
reference.
Yeah.
Brian, there's
We'll
always
start with that next.
Okay.
The
I'm
next
gonna
week.
shut people down because I have shit I have to do.
Okay.
We've all been very excited, and Matt, I hope the links make it into from the chat into the doc.
Yeah.
Just Ryan, one quick note: it's value semantics versus reference semantics, and I would recommend
Probably
Philo
just
as one
stop
of
the
the
recording
languages
and
to
leave the
look
room
at.
open. Bye.
Everyone's very excited here, and it's very, very informative and enlightening. How do we call it? Not aggressive, energetic discussion.
Passionate.
Passionate discussion. People's passions about equals. Okay. Well, we can always revisit this next week, and maybe people bring some, examples and docs as to why this versus that. But maybe we'll come to an answer at some point. Until next week, folks, it's been very fun. Bye-bye.